are still a little bit confused, but looks like most answers are pretty good. Here we go.
Please remember when you want to find x intercept before the 0 for y. So if I put the 0 for y, 3 times 0 will be 0. So it's just like taking that out. So all you're left with is 2x equals 12 when you put the 0 for y, which means x is so around that is ordered pair, we got an x of 6 for a y over 0. So there's our x intercept. To find our y intercept, we're going to put a 0 for x. 0, 0, so it's just like taking that out. So all you're left with is 3y equals 12, which means y is 4. So we had a 0 in the x spot, we got a 4 in the y spot. There are your two intercepts. Good job.
Most of you remembered that pretty well. We're going to cover the last section over this today, and Thursday we're going to have a test over, okay? Stuff today is a lot of functions. If you need to label, just label functions. It's not very hard. And this was, I won't say that, never mind. Thank you. What I've written there, that is called a relation. Okay? Definition on that, that is a relation, R-E-L-A-T-I-O-N, I think. A relation is just a set of ordered pairs. So it's a set of ordered pairs. I know it's a set because it's in those braces. That is just a relation. The directions, the question asks us to determine whether this is a function. Okay, and there's several ways we can look at stuff and decide whether or not they're functions or not. When they give us an ordered pair, to check and see if they're functions, we look at the x value. Your x value and your x coordinate in the ordered pair can only be used one time. Each x can only have exactly one y. So I look at the first ordered pair here, I got a 0 in the x. None of these other ones have a 0 in the x. So far so good. But then I go to this one, it's got a -1 in the x. So does this one. So I got -1 twice in the x. So because of that, because I've got the same x being reused, this is not a function. Okay? Am I remembering this stuff from many moons ago? Alright, so if we had something that said, had a relation that said 5, 4, 6, 4, and 7, 4. The directions ask if that is a function. Would that one be a function, yes or no? Yes, Blake and Angie are correct. Yes, it would. A lot of people will look and say, well, you got 3 4s in there. They're not the x spot. It's the x spot that matters. So I've got 5, 6, and 7. That's all different. So yes, that one is a function. It's the x that you're concerned with when you're testing for a function. Okay. Alright, I guess I got out of order on my bullet points up there. Relations and functions was second. Independent and dependent variables. We know we're talking about x's and y's and all this stuff, so I'll just label that up here on this, down here on this one. Your dependent variable is going to be your y, and your independent variable is going to be your x. Okay, because you think of the input-output table, remember when we make these things over here, what we plug in for the x, we get out for the y. So our y depends on our x. There was something when I used to teach middle school math, there was a little an acronym, and I can't remember what it was now. I think it was Roy. Let me see if I can remember that first, real fast. Roy, because that was your range output. Don't need two O's in output, don't you? And that's your Y. Roy Dac? No, Roy. Domain. Endpoint. I guess it's. And then X. I guess that's what it was. I don't know. I can't remember that long ago. Drain my white marker. Alright. So, anytime it asks you for the independent and the dependent variable and you're not sure, your independent is your X and your dependent is your Y. Domain and range, we can label that same stuff while we're here. Domain is always your X and range is always your Y. So let me scroll up here and say X we know now is the independent and it is also the domain. Y we know is the dependent and it is also the range. Alright, we got what we need out of that, pretty simple. So this, I've got an input-output table here. It's got the year in the X column. And sometimes you'll be given a table like that, and you're like, well, I don't know which one is Y and X. Well, the X always comes first in your input-output table. So year, and then this is subscribers, SUBSCRIBERS, subscribers in thousands. I'm not going to write the in thousands there, but it's in thousands. So it says we got 1999 up to 2004. And we got 86,047, 109,478, 128,375, 140,776. Yeah. After 140, 158, 722. And then my last one is 182, 140. Alright, this data here, it says, is cellular telephone subscribers during those years. First off, it says, is that a function? Okay, you don't have any year used more than once over here. In this kind of data, it pretty much has to be a function because you can't say, and this is common sense, you can't say in the year 2000 there were 109,478 telephone subscribers, and also in the year 2000 there were 140,000. I mean, which is it? It's one or the other. That's data that's collected. So you're never going to have an X that's reused in that type of problem. So yes, that's going to be a function. Okay. Then it says, next question is, what is the domain? I want to show you how we got to write this. So the domain we know is the X. We're going to put this in set notation. So I'm going to say my domain is equal to the set, and then I'm just going to list my years. My domain is the X, so my years 1999 up to 2004. It'd be better if I'd have had more room and spreaded it all out, but there's the domain. I'm not gonna right now, but the range you would do the same way. You would write it as your range is equal to the set, and then you would just write all those out. Does it matter what order you write them in? They need to be corresponding. So I stayed common sense wise and I wrote the domain in the order they went in. So 1999 corresponds with that one, so I would need to write that one first. So if you're like, well, I want to put these in reverse numerical order or whatever, well, they need to correspond to their X value. So I should be able to look here in the domain at the third number and then go to the range and it be the third number, its corresponding value. Does that kind of make a little sense? Don't mix them all up. Alright, so we did domain, we did range, we did function. Alright, we told that yes, this was a function based on our x values. Do you remember how to tell if it's a function when you're just given a graph? Okay, remember that? Oh, Scout, I thought you was going to have it there. Close. So you're looking at a line to see if it crosses it twice, but it's not the x-axis. Very good, Kelsey. The vertical line test. Test and see if something's a function or not on a graph doing a vertical line test. And I always tell you on your paper, you can just hold your pencil vertically and slide it across the graph and see if it ever touches that line more than once or not. Okay? I think sometimes I can do this on here. We'll try and see. Alright, there's my vertical line. If I move that left to right across my graph, is it ever going to touch it more than one time? Like right now, it's touching it once. Right? So, is it ever going to touch it more than one time? No, so that one, yes, is a function. Okay, so what's a kind of graph, what would something have to look like that's not a function? What about that thing? Right now, where my vertical line is on that, it's touching it twice. So that would not be a function. What about a parabola? Is a parabola a function?
It can be.
Okay, good. An opened up or down parabola, like right there, that one is a function, yes. But what about if it's turned sideways?
No.
Good. A sideways one would not be, because that would touch it twice right there. Okay, so y'all are familiar and remember all of that. Alright, the ones that are sometimes give us the most trouble, well, that looks like a bunch of mumbo jumbo if you just walked in and saw that on the board. What are they doing? They're learning shapes, I don't know. The ones where it gives you just the equation and asks if it's a function or not are the ones that sometimes people struggle the most on. So this first one I got here says y equals negative 2x plus 7. And it asks us if that's a function. And now one thing you can always do, because y'all have all got access to the graphing calculators, you can, as long as they're solved for y, you can plug them in y equals on your graphing calculator and check a vertical line test on the picture it gives you on that. You can do that. Okay, that's fine with me. This one's pretty simple to tell because I know that that's in a line. That's mx plus b. That's a linear. The only kind of line that will never pass the vertical line test is a vertical line, right? So this is not going to be a vertical line because it has a slope of negative 2, so it's going to be going downhill. So that one, yes, is always going to be a function. Every line will always be a function except for a vertical line. Now, to say this out algebraically, any number I plug in for x, I'm going to have to multiply it by negative 2 and add 7 to it, right? So could I plug a 1 in for x and get two different answers? No. When I plug a 1 in, multiply it by negative 2, add 7, it's going to be that same answer every time. It's going to be 5 every time, right? I can't get a 5 out of this for 1 and then get a 7 next time. It's going to be the same answer every time. So yes, that will be a function. Now if we had, this one says y equals the square root of 5x minus 6. Is that one a function?
Yes.
Heard a yes, and some people are looking at a graph on their calculator. Or a no? What's the square root of 4? Since this has got a square root in it, let's stay basic. What's the square root of 4? That's half the answer. else can I square and get a 4? No. 2 squared equals 4. Negative 2 squared equals 4. So when I'm dealing, listen, when I'm dealing with a square root, it is possible for me to have 2 answers. Because the square root of 4 can be positive or negative 2. Right? So it's possible for me to plug something in for x and get 2 separate values out on that. So if it's a square root on that, that is me plugging in for the x but getting 2 separate ones out for the y. And so Austin was right when he said yes, that is a function. And that was tricky to people, and I was trying to make sure you see that this is the x, and so I got different x's, the same y. You can have the same y, right? It's the x's. Those x's are different. So, a little tricky on that one. But yes, that would be. I think when you graphed it, if I'm not mistaken, when you graphed those of y'all that looked at, did it look kind of like a half parabola kind of thing? Yeah. That's what all square root graphs will look similar to. Alright, now if we had, this one says y to the 4th equals x. Now, as that one is, you can't plug that one into your calculator. It would need some work to be done. Y to the 4th equals x. Do you think that one is a function or not?
I think it is.
Got a possible yes from Blake. Anybody else? Let's look at, since this one says y to the 4th, let's look at what happens if we plug a 2 in for the y. What does 2 to the 4th get me? 2 is 4 times 2 is 8 times 2 is 16, right? What if I plug a negative 2 in for the y? What's negative 2 to the 4th? It's also 16. So this one is going to be a no, not a function. Alright, now looking at an inequality, which is what we did on Thursday last week, still testing to see if it's a function or not. This one says y is greater than or equal to 4x plus 2. Now if that was an equal sign, that would be a line, and we would say yes, it's a function. Okay, but it's not an equal sign, so we know that there is some shading that's involved in this. So let me graph this real quick for us. This is slope-intercept form, mx plus b, so it's going to cross the y-axis at 2. And then it's going to rise 4 from there, 1, 2, 3, 4, and run 1. Okay, it'll be a solid line through those points. I want to do my favorite test point. All this that I'm doing in warp speed right now is stuff y'all did last week, so y'all ought to be able to do this. I'm going to plug 0, 0 in and test that. Y is greater than or equal to 4 times 0 is greater than or equal to 4 times 0 is 0 plus 2. 0 is not greater than or equal to 2, right? So I can't shade 0, 0, which means the other side gets shaded. Okay? So that's stuff that we looked at last week. Now, is that a function? Everything that's scribbled up there is part of my answer. So if I were to do my vertical line test through that, I'm touching it all over there, right? So because of that shading on that, no, that's not a function. So that inequality is what made that no, not a function. What's the matter? So I got the what? Sniffles. I have the life sucks. Is that an option?
Wow. Life sucks. Life does suck. I wish I could just sleep all the time.
Well, that would be bad.
because then I dream good things. Yeah, I know.
Alright, let's talk about domain and range and some of this stuff. This one, if we go back to a linear, this is an equation. It's got the equal sign right there. So it's just y equals x plus 4. Is that a function? Yes, we said all linear things other than vertical are functions, and this is equal, so we didn't have to worry about the shading. So what would the domain and range of this be? Okay, if I looked at this on a graph, just to give you an idea, y-intercept is 4, slope is 1, so it would be rising 1 and run 1, so it would just be a line looking something like that, perfectly straight. All right, x, domain, right to left. Is this line ever going to stop? No, so its domain is going to be, and this is where we'll write it a little bit differently. It goes forever to the left, which is negative infinity, and forever to the right, which is infinity. What about its range? It's the y. Is it ever going to stop going up or down? No, so its range would also be negative infinity to infinity. You could plug any x in you wanted. You could plug 9 million in and get a y. You can plug negative 20 million in and get a y. So there's no limit on what you can plug in on that. Okay? What about a square root one that we looked at a second ago? Here's a different one. Y equals the square root of 2x minus 1. Want to know what the domain and range of that would be? We said it was a function earlier. What would its domain and range be? What does this square root limit us to? What can we not have underneath a radical and still be a real number? A negative. So I know that this 2x minus 1 needs to be greater than or equal to 0, right? So I'm just going to solve that. 2x is greater than or equal to 1, which means x would have to be greater than or equal to a half. Okay, so my domain on this, the smallest it can be is a half, and it can be a half, so I can touch that, it gets a bracket, but then it can go up forever. Okay, so that'd be our domain. I did range on that last one, but I'm looking in the book and all they ask for is domains, so we'll just do domains right now. Alright, let's look at a fraction one. That's where the domain gets even more particular. This one, it had to be greater than or equal to 0, just remembering, because if there was a negative underneath that radical, that's non-real, that's imaginary, and we haven't done imaginaries yet again this year. Okay, fraction one. Y equals 5 over x minus 1. First off, is this a function? Am I going to get, is it possible to get multiple x's here? No. Whatever I plug in for x is going to get me a different y, isn't it? Yeah. So yes, this is going to be a function. Alright, this is a fraction. What limits do we have on what can be on the denominator of a fraction?
X cannot equal 1.
That's the right answer, but why can it not equal 1? What's the limit?
You can't divide by 0.
Good. You can't have a 0 on bottom of a fraction because that would be undefined. So Blake already, and the rest of y'all can already know what would make that a 0, but if you don't know, take the denominator, set it equal to 0, and solve. If my x were 1, that would make that a 0, and it can't happen because 5 divided by 0 is undefined. So to write that as far as my domain is, I can be to the left forever, all the way up to 1, or I can go from 1 all the way to the right forever. Okay, that's one way to write it. This is domain. Just showing you all the ways, so in case you see a different one on your test. Other way to write it is what Blake said, and I would probably write it that way as well, but I want to show you this because this is what our book has, and that's who prints our tests, so you need to make sure. But x can be everything except for 1. So those two things mean the same thing, just need to be familiar with the different notations.
Yeah. But how, okay. I'm gonna sound so stupid asking this question.
I know.
You said X can be anything but 1, then that one X is.
Right here where we solved it, because we set it equal to 0. To see when it's equal, when this equation was equal to 0, what made it equal to 0? A 1 made it equal to 0. But you can't have a 0 on bottom, so we can't have that 1 that makes it equal to 0.
Okay.
Does that help any? No? Okay. I remember y'all were doing that because that was one of the days that I helped Wayne on this stuff, his functions. Alright, next thing that we got is pretty easy. If I gave you f of x, and by the way, this f of x, most of the time, y'all know it means the same as y. That's right, Austin. That just means it's a function as well. So they're writing that in function notation. So if they ever say f of x equals and ask you if it's a function, they wrote it in function notation. So of course it's a function. F of x equals negative 3x plus 5 over 2. This wants us to, number 1, find f of negative 3, and number 2, find f of t. Okay, that's usually when it gets confusing to people is when we put the variables in it. F of negative 3 just means we're going to take negative 3, we're going to plug it in for our variable and solve. So I write this now, I'll say f of negative 3 equals, lots of times I leave that off, but f of negative 3 equals, now I'm going to plug the negative 3 in. Negative 3 times negative 3, because I put it in the x spot, plus 5 over 2. So that's 9 plus 5 is 14, divided by 2 is 7. So f of negative 3 is 7. There's your first answer. Okay, the second one now says find f of t, and you do that the same way. On number 1, we plugged a negative 3 in for the x. This one's written the same way. You just plug a t in for the x. So it just will be f of t is equal to negative 3t plus 5 over 2. That'd be your answer on that one. Okay, so drag that out a step. Break out what you need off that. This one says g of x equals 5x minus 1. It says to find and simplify g of m plus 2. G of m plus 2. Alright, so g of m plus 2 is going to be equal to 5, but instead of an x, we put m plus 2. You always put it in the variable spot. Okay, so there we got it plugged in. Now what do we do to simplify that? Distribute, so that gets me 5m plus 10. Still got that minus 1. I can simplify that one more step. 10 minus 1. So that'd be my answer. Now, the function, the stuff we were just doing there, finding different values of the functions, that does get more complicated. But I was looking to see when we get more complicated with it. We don't yet, I don't think. Let me just glance through there and make sure I've done do one of the hardest kinds of those real fast. Alright, let's do if I had f of x equals negative 3x plus 4, and I want to find what is f of x plus 2. Okay, so what we're going to do on this, you're just going to take what they're asking you to find and plug it in for the x. Okay, so I'm going to write -3 times x plus 2 plus 4. Which now what would we do after that? Distribute, so we got -3x minus 6 plus 4. Which combine those like terms. That's it. Who are you making fun of her for? What's she doing?
She was way off. She goes, boom, done. And then she looked at mine, she goes, oh, well, how'd you get that? And then you know the same thing I did. And she was like, oh, what did I do?
Well, the last one's not done. I don't know why I can't keep not putting me in negative, but I do.
Alright, let's look at one more of those. We're about ready. We're about done. Hold on. Let's look at same f function, f of x equals -3x plus 4. This time we're going to find f of x plus h. Okay, so I'm going to take x plus h and plug it in for the x. -3 times x plus h plus 4. It's just substitutions, all we're doing on that. So it gets us -3x minus 3h plus 4. Can you simplify that any? Nope, that's your answer. Alright, I do want to do one more. Let's do one more. Do one where we get a number answer. Alright, same f function, f of x is -3x plus 4. I've got a g function this time as well. G of x is -x squared plus 4x plus 1. We're going to find f of 10 minus g of 10. Okay? So first thing we got to do is find f of 10. Now, this is common sense, but people will screw this up. If I'm looking for f of 10, do I want to put this 10 in the f function or the g function?
The f.
The f function. Okay, that's pretty tough, but people will mess that up. Well, I don't know where to plug it in. Well, you plug it in the one they tell you to. So I've got -3 times 10 plus 4, which would be -30 plus 4, which would be -26. So f of 10 is -26. Now if I'm going to subtract g of 10, I got to figure out what g of 10 is. So I'm going to take 10, and this is g of 10. I'm going to plug it in the g function, but there's two places on that one to plug it in, isn't there? So that's going to give me negative. Now look, that negative stuck out in front, so I'm going to write mine like that so I don't get it mixed up. Plus 4 times 10 plus 1. Because this doesn't say to do this up here where I highlighted, it doesn't say to do -x squared. The way that's written, it says do x squared and then make it the negative. Y'all see the difference on that? If they'd put it in parentheses, they'd have wanted you to do -x squared. So we're going to do 10 squared is 100, and then make it the opposite, be -100. Plus 40, plus 1, so that's -60, so that's -59. So back to our problem here, it says f of 10, so -26 minus g of 10, so minus -59. So what's -26 minus -59?
33.
That is correctamundo.
I hated the way she talked to you.
Alright, tomorrow we'll start with some study guide stuff and then finish that up and be ready for our test on Thursday.